Hey everybody, so hopefully you were watching this after you've watched the initial video about how R deals with data, how R thinks about data. The initial video was all about just sort of vector objects and storing numbers and strings and true and false values as some sort of object in R. What this video is about how to subset vectors. So we talked about combining vectors using that concatenation function, among other things. Sometimes you want to pull things out, right? And you can think about all sorts of scientific tasks where you might want to do that when you're sort of like curating and filtering and subsetting a data set. So to start with, let's make a vector that we'll play with. I'm going to use the one shown in the course materials under the subsetting vectors tab. So create it called animals, use that double caret. We're going to use the concatenate function to combine the strings for mouse, rat, dog, and cat. Use my typing there. Okay, so now we have that animal vector. Let's try the str function to just look at it. Boy, typing struggles here. So you've got that 4-unit long, 4 strings, we're good to go. All right, so a couple different things we can do to subset. One, R is really good about thinking about the location of objects within a vector. So what I mean by that is you can use any number representing the location of a particular item in a vector to pull that item out. So let's say rat is the second item, or you just want to see what the second item is in the animals vector. If you go animals, and then in brackets, and brackets is how you tell R that we are indexing, which is a fancy computer term for like we're pulling out an item that corresponds to a particular location. So index the second value, it's going to spit out rat. Let's say you want to pull out multiple values. In this case, we need to create some sort of vector to subset the vector. The reason being, if you just do something like this, 2, 2, or more confusing, 1, 2. R doesn't quite know how to handle that because it thinks it's a matrix. We'll talk about what that means later. Instead, we need to create some sort of index value, another vector, to pull out multiple items. So something like concatenate 1, 2. If we print that in the screen, we can say that's a vector of the numbers 1 and 2. If we drop that into animals, it's going to pull out the first and second item, mouse and rat. Now, the cool thing is, it doesn't have to be in order. So you can actually call 2, 1. It's going to pull out rat and mouse. So the key there is it obeys the order you give it, pulling out the indexed item. It doesn't pull out the first and second items in that original first and second order. It goes through that vector and it says, give me the second item, then give me the first item and return both of them. Building on that, you can return the same item multiple times. Watch this. If we concatenate 2, 2, and 2, it's going to return rat 3 times. So again, playing around with this right now, it just kind of seems like silly operations. But once you get into, you can think about like if you've learned bootstrapping in statistics, for instance, this is kind of an easy way you can start to do something like that. If you've never heard of bootstrapping, just ignore that and skip that part of the video. Okay, next item, we can also use Booleans to do what's called conditional subsetting. So there's a couple ways we can do that. So the first one is simply feeding in trues and falses. So let's say we wanted to return the first and third items of that animals vector, but not the second and fourth one. We could do something like this. And again, we always have to concatenate. So let's say true, false, true, false. What R is going to do here is it's going to look at those and it's going to say every time I see a true, return that item. Every time I see false, don't. So now we have mouse and dog. A couple features to build off this. Has to be the same length as the item we're trying to index. So if we add another true here, R is going to throw an error. It's going to say NA, weird result because there was no fifth item. So it's trying to return a fifth item that doesn't exist. What if we return fewer, true and false? In this case, R recycled the true and false for the length of the vector. That also has somewhat dangerous properties, so we'll talk about that later. You don't really want to mess around with that. So that's feeding in direct trues and falses. One other thing I'll note quickly here, in case we forget to mention it in another video, R treats capital T's and F's the same way it treats full spelled out trues and falses. So if you feed in capital T's and F's, you get the same behavior. Right. So that's one way to conditionally subset, just with raw Boolean values. But the other thing you might want to do, and this is actually for data filtering, is you might want to filter actually based upon the actual value, say return numbers that are above a certain level. So let's make a new weight value, and we're going to say catenate 101, 99, 88, 112, and 105. So 5 units long, if we call str on that, it's going to tell us it's a numeric vector, 5 units long, spits out the numbers. So let's say we want to keep only weights that are less than 100. We could do something like this. Instead of feeding in a different vector, we're going to feed in that same weight vector into the index brackets. And instead now we're going to say weight is less than 100. We run that, R is going to return the 2 items that are less than 100. What's actually going on there? Well, let's run just weight is less than 100. R spits out a Boolean vector. So we've just created our own Boolean vector based upon the filter protocol that we desired. In this case, is each number in this set less than 100? So now you can see we've built sort of an easy way to filter and subset data. You're likely familiar with the greater than and less than signs. That's awesome. You can add an equal sign. So in this case, let's say we want to do greater than, less than or equal to 101. It's going to spit out 101, 99, and 88. Likewise, you can do the same thing with greater than as well. Lastly, we can combine filters. And so let's say you want to return a case where weight is, do this below, weight is less than 99, one case there, or weight is greater than 110. So each of those is a Boolean vector on its own. If we combine those using the vertical line I never remember the name of, but it's essentially R's. That vertical line is the OR sign for conditional operations. If we run both those, we're going to get 2 true values for where we see either something that's less than 99 or something that's greater than 110, which is 88 and 112 in that fake vector we made, or that not fake, in the sample vector we made. So now we can index with that combined operation, and it's going to spit out 2 numbers, 88 and 112. So the combinations here are essentially infinite. You can build any sort of like greater than, less than combination packages. The only trick is sort of the limit of your imagination in terms of keeping straight all the trues and falses, how they line up, because it'll only return something where the condition is satisfied or vice versa. The other thing to note is that we can do that with strings as well. It doesn't have to be numbers. The way that's going to happen is we're going to do like exact matching. So with that animals vector, we're going to do something like animals. I want you to return the case where animals equals mouse. So what the equals here, the double equals is doing is it's saying, are these 2 values the same? And so if we run that just to create the Boolean vector, we see the first case is true, the others are obviously false. And so if we index using that same feature, it's just going to return mouse. Now we can build on that in all sorts of ways, just like we did with the numbers. We can say return the case where animals equals mouse or animals equals rat. It's going to return both those. Don't forget that double equal sign behaves differently than the single equal sign. The single equal sign is another way of assigning an object. So we can say test object using that equal sign. If we say test equals test object, we're going to get a Boolean result, in this case true, because we already assigned it that way. But if we run test equals something else, it's going to say false because we're making a comparison, we're not assigning an object. So that's one reason why in class we always try and use the caret, the 2 combo to assign an object, so we can keep straight when we're using a Boolean and when we're doing object assigning. Okay, there's a couple challenges I want you to check out at the bottom of this discussion. There's also, and I think because the video's getting a little bit long, I'm going to skip over the special in function, and maybe we'll go over that in class. And yeah, let me know if you have any questions. Thank you.